Hello IB. Here in 18E.2, what we're doing is finding a method where we can actually get the value for the C, or the constant of integration. If you've given values for a point on the antiderivative function, then you can solve for that constant. So that means if we know a point on the original function and we're given the first derivative, then we can get the constant. If we've got the second derivative function and we're trying to find the original function, then we're going to need a point on f dash x as well as a point on f of x. So we'll look at that second one in class. So let's start off with this first, the simplest case, where we're given a derivative function, f dash of x equals 2x minus 1, and we know that at f of 0, the value of the function is 3. So let's integrate that to find our original, the primitive function. So we want our integral of, remember, integral of our derivative function with respect to x, because we're working in x. That's going to give us our original function, but the thing that's missing here is a constant. So we don't know what that is. That's what we're trying to find out. So let's now integrate our 2x minus 1. And remember, we've got two terms here, so we need our brackets around, dx. Integrating that, we're going to add our power. This is a power of 1, so we're going to add our power of 1 to make it 2x squared. And we've got a 2 in the front of that we divide by 2 because that's our new power, minus integral of minus 1 is x plus c. Now we know, let's cancel that. So we can cancel those, and we're left with x squared minus x plus c. We're given in here that, I'll shift this up a bit higher, we're given that f of 0 equals 3. So in other words, we can say that 3 equals 0 squared minus 0 plus c. In other words, c is equal to 3. So now we can say our original function, the primitive function, must have been x squared minus x plus 3. The next example, which we're going to do in class, is where we're given the second derivative, happens to be 2x plus 1, and we now know a point on the first derivative, so that's going to allow us to work out the constant from our first integration. Then we want to integrate that again, so we're going to integrate, but we're going to get a constant, and we can use that to solve for our constant. Then we're going to integrate again. We're going to get our original function, but here we'll have another constant, and we'll call that, say, d, because we can't use c again. And with this information, we'll get the value of d, and so we'll end up with our original function, and without having any plus c's or d's in it. Anyway, have a go with that, and then we'll start off with that in class. So a quick, easy video today. Thanks for listening. Bye for now.